Welcome to Mr. Math's Grade 11 Equations. Today we're going to look at a whole bunch of different equations that you can get and how to solve. So, first of all, we're going to have a look at the rational exponent type of equation over here. And the first thing we want to worry about is how to deal with this, right? So what you want to do, there's a whole bunch of ways to do it, but sometimes the easiest way is to just turn that into an x to the power of a third squared equal to 4. We'll just leave as 4 for now. Why do we want to do that? Well, there is a method of solving called k-substitution. So what we're going to say is we're going to say let k equal x to the third. That means I get k squared equal to 4. Now, as we know, hopefully k squared minus 4 is the difference of two squares. So we could write it as k squared minus 4 equal to 0. Or you could just take the square root of both sides and we get k is equal to 2 or k is equal to negative 2. I now replace my k with a x to the cubed equal to 2, and I do the same on this side. Now, another way to look at this is by doing basically what we did here. We cube both sides and I end up with x equal to 2 cubed, which is 8, or x equal to minus 2 cubed, which is also 8. So it's 8 but because of the negative, it's negative 8. And so those are my two answers. Beautiful. The next one we're going to have a look at is 2 to the x equal to 1 over 16. Much easier than the first one, but what we've got to remember is I want these to have the same base. Currently this is a whole number and this is a fraction. So what we can do is we can say 2 to the x is equal to 16 to the minus 1. Just bringing that denominator up. I can't change 2 because it's already a prime base. 16 I can change into 2 to the 4. With a minus 1 on the outside. Now, 2 to the x is equal to, if I distribute that, I get 2 to the minus 4. Now, because I have the same base, I can drop them and say, therefore, x equals negative 4. And that is then our final answer. Last one, a little bit more difficult, but still dealing with the idea of exponents. As you can see here, I have a 2 to the x that is common. So if I take out a 2 to the x, that leaves me with 5 plus 3. Now remember, this 2 to the x that I've taken here, I've still got to leave the exponent with a base. So it'll be times 2 squared equal to 68. This gives me 2 to the x. If I simplify this, 5 plus 3 times 4, which is 12, it gives me 17 equal to 68. What I want to do now is I want to divide both sides by 17. That'll leave me with 2 to the x equals 68 divided by 17 is 4. And I'm back to somewhere over here. Similar kind of question. Change this 2 to the x into 2 squared, and so therefore drop my base, x is equal to 2. And there we have it there. Okay, having a look at one more complex exponent. It's a little bit more difficult, but what you can hopefully see, or at least you need to be able to see, is this equation looks like it's in the form of a quadratic. Now, quadratic is something squared plus something plus or minus a constant. So here I have 2x and here I have x. So what you actually want to look for is that your highest exponent is always double the next one. So 2x is double x, and then the other one doesn't have an exponent. That's generally a giveaway for when something is a quadratic equation. Now, our options, depending on how comfortable you are, we can do k-substitution, and we can say let k equal 3x, right? And so therefore k squared is equal to 3 to the 2x. Now what I've done is I've just made it into k squared plus 6k minus 27 equal to 0. From here, I want to factorize. Okay, so from here we know that 27 comes from 9 and 3. 9 is plus, take away 3. I end up with k equal to 3 or k equal to negative 9. What I want to do now is bring back this original question. So I'm going to say 3 to the x is equal to 3, or 3 to the x is equal to negative 9. Now this one is easy because I just know that 3 and 3 to the power 1 is the same. So therefore x is equal to 1. The other side is a little bit more tricky. I can do that, but what I've got to remember is that no matter what I do here, 3 to the x will never produce a negative output. So 3 to the 1 is obviously 3, 3 to the 0 is 1, and 3 to the negative 1 just becomes 1/3. So actually, exponents never produce negative outputs. So in this case, my answer on the right hand side is not applicable, and only x equal to 1 is the correct solution. Now, having a look at the surd on the right hand side, very simple. Leave the surd on one side, move everything else to the other. So that's going to leave me with 3x minus 2 equal to x. What I want to do now, square both sides so that I can eliminate that surd. I get 3 to the x minus 2 equal to x squared. You should hopefully see that the x squared, the x and the constant make something that is a trinomial. Move everything to the other side. Remember, 3x becomes negative 3x and negative 2 becomes plus 2. I now want to factorize this. So x in both sides, don't forget your 0. 2 and 1 gives me 2. Both of these are going to be negative. Negative 1 minus negative 2 gives me negative 3, and when I multiply, I get 2. So that works. So therefore, I get x is equal to 1, or x is equal to 2. Now what we've got to just do quickly is check or do a little test to see if these solutions work out. So 3 to the 1 minus 2 gives me 1. Under the square root is 1, so that works. And 3 to the 2 minus 2 is 6 minus 2 is 4 under my root sign. So 4 gives me 2, so that also works. So both of these solutions are workable. Beautiful. What we're going to have a look at here is a quick quadratic equation. Obviously we've just done some quadratics, but this is a bit more grade 11 specific, where we're dealing with the use of the quadratic formula. Now, I have put it here on the side for us. It is given on the formula sheet in grade 12, but it is very helpful to know, and you end up using it a lot, so you should try memorize that. Where does a, b, and c come from? In my quadratic equation, in standard form, it looks like that. So whenever I get my quadratic, to standard form, it's always the coefficients of x squared, x, and the constant. So let's have a look here. Is this in standard form? No, it's not. I've got to move the 36 over. And now we have a quadratic. So, what are my values? A is equal to 1, B is equal to 9, C is equal to negative 36. I can now plug this into my formula, and away we go. So, we're going to say x is equal to minus b, which is 9, plus minus 9 squared minus 4a c over 2a. Now, the good news about these is you most definitely want to use a calculator. So I can say minus 9 plus minus, that whole equation becomes square root of 225 over 2. Now the key here is to remember that a quadratic equation always gives me two outputs. This plus minus is where I get those two outputs. So I'm going to say the first one will be minus 9 plus the square root of 225 over 2, or x is equal to minus 9 minus the square root of 225 over 2. Now if we simplify those two, we get, first one here is x equal to 3, and the second one, all you do is you just go back to your calculator, you change the plus for a minus, and you end up with x is equal to negative 12. Now, what is nice is actually, because these are whole numbers, we could have done the calculation without the quadratic formula, but the quadratic formula works for all quadratics, so it's good to know that we can test our answers. We have a simultaneous equation. Okay, so here's our two equations. Y is equal to x squared minus 1 and y minus x is equal to 5. Now, simultaneous means solving for two variables at the same time, or basically using two equations to solve for two variables. Now, something to remember as you get further in maths, the number of variables must equal the number of equations. So if you have two variables, you need two equations. Three variables need three equations. That is how you solve. That's why linear has one variable and you only have one equation. Now, what we do first, we isolate one of our variables. In this case, the y is already isolated. So what I can do is I can take this expression for y and put it in that expression for y. So what you end up with is x squared minus 1 minus x equal to 5. So remember, this part here is the substitution of y. So we end up with x squared minus 1 minus x equal to 5. Because of the x squared, it's definitely going to be a quadratic. Minus x minus 1 minus 5 equal to 0. Simplify that expression. Minus 1 minus 5 is minus 6 equal to 0. And so I end up having to factorize again to x and x, 3 and 2. What do I want? I want a negative 1, so that's got to be negative and that's got to be positive. So therefore x is equal to minus 2 or x is equal to 3. Now, that's not the end because I have a y to solve for. So what I'm going to do is I'm going to take both of these and I'm going to substitute them for x in that equation. Remember, we used this equation first, so now to find, we want to use the other equation. So y is equal to 5 plus x. I've just rearranged this. Therefore, we have y is equal to 5 plus, we're going to substitute this one in first, 3 and so I get y is equal to 8. So therefore, I have 3 and 8 as my answer. I'm going to redo it this side with the other one. Y is equal to 5 plus, what am I going to put this side? A negative 2. And so y is equal to 5 minus 2, which is 3. And so I have minus 2 and 3 as my other set of values. Remember, it's important, you want to always find an x value and its matching y value. That's what simultaneous equations are about. Now, a quadratic generally has two answers, so here's a quadratic. So that's why I have two x's and two y values. And that is a quick, brief overview of the different types of equations that you can get in grade 11. I hope this has been helpful. See you next time for Mr. Math's 10-minute videos.